Insects as human food. Entomophagy is the consumption of insects as food. The eggs, larvae, pupae and adults of certain insect species have been eaten by man since prehistoric times and continue to be an item of the human nutrition in modern times. While insects are eaten by many animals, the term entomophagy is generally used to refer to human consumption of insects. Animals that eat insects are known as insectivores. There are also some species of carnivorous plants that derive nutrition from insects. Human insect eating is common to cultures in most parts of the world, including North, Central and South America, and Africa, Asia, Australia and New Zealand. Over 1,000 of insect species are known to be eaten in 80% of the world's nations. The total number of ethnic groups recorded to practice entomophagy is around 3,000. However, in some societies, insect eating is uncommon or even a taboo. Today, insect eating is rare in the developed world, but insects remain a popular food in many developing regions of Latin America, Africa, Asia and Oceania. There are some companies that are trying to introduce insects into Western diets. History. Before humans had tools to hunt or farm, insects may have represented an important part of their diet. Evidence has been found analyzing coprolites from caves in USA and Mexico. Coprolites in caves in Ozark Mountains were found to contain ants, beetle larvae, lice, ticks and mites. Evidence suggests that evolutionary precursors of Homo sapiens were likely also entomophagous. Insectivory also features to various degrees amongst extinct primates such as marmosets and tamarins. And some research suggests that the earliest primates were nocturnal, arboreal insectivores. Similarly, most extant apes are insectivorous to some degree. Cave paintings in Altamira, North Spain, dated to 30,000 to 9,000 BC, depict the collection of wild bee nests, suggesting a possibly entomophagous society. Cocoons of wild silkworm were found in ruins of Shaanxi province of China from 2000 to 2500 years BC. The cocoons were discovered with large holes, suggesting the pupae were eaten. Many ancient entomophagy practices have changed little over time compared with other agricultural practices, leading to the development of modern traditional entomophagy. Examples of entomophagy. Entomophagy can be divided into two categories: insects used as a source of nutrients and insects as condiments. Some insects are eaten as larvae or pupae, others as adults. There are a plethora of cultures that embrace the consumption of insects. These include 235 species of butterflies and moths, 344 species of beetles, 313 species of ants, bees and wasps, 239 species of grasshoppers, crickets and cockroaches, 39 species of termites as well as 20 species of dragonflies amongst others. Other commonly eaten insects are termites, cicadas and dragonflies. Insects are known to be eaten in 80% of world's nations. Insect-based ingredients are beginning to be incorporated into more mainstream foods such as protein bars and baked goods. The primary vehicle for this so far has been powder made from insects utilized as an ingredient, often referred to as insect flour, cricket flour, cricket powder or whole cricket powder. For example, one company in the United States called All Things Bug LLC is currently manufacturing hundreds of pounds of whole cricket powder and selling wholesale to other small startup companies who utilize it in protein bars, baked goods and other products. Eating insects has not typically been adopted in the West. However, a few companies are aiming to introduce products made using insects. The commercial exploitation of food insects has led to their decline in some places. The consumption of Atta levigata is traditional in some regions of Colombia and northeast Brazil. In southern Africa, a species of moth called Gonimbracia bellina is found throughout much of the region. Its large caterpillar, the mopani or the mopane worm, is a source of food protein. In Australia, witchetty grub is considered a source of food amongst the indigenous population. Entomophagy has been featured on some reality television shows such as Fear Factor. Barrington Hall, a former student cooperative at the UC Berkeley, held an annual insect banquet for many years until the co-op was closed down in 1990. Theme park operator Six Flags Inclusions, based in New York, staged a contest as part of a promotion leading up to Halloween, in which it also offered customers free entry or line jumping advantages if they ate a live Madagascar hissing cockroach. The People for the Ethical Treatment of Animals, called as PETA, opposed the overall promotions. Insects do not deserve to be eaten alive, especially for a gratuitous marketing gimmick. PETA spokeswoman Jackie Verigio told Reuters. Advantages of eating insects as human food. Number 1. Mini livestock. The intentional cultivation of insects and edible arthropods for human food, referred to as mini livestock, is now emerging in animal husbandry as an ecologically sound concept. Several analyses have found entomophagy to be more environmentally friendly alternative to traditional animal livestocking. Edible insects have long been used by ethnic groups in Asia, Africa, Mexico and South America as cheap and sustainable sources of protein. And the major role of entomophagy in human food security is well documented. Up to 2,086 species are consumed by 3,071 ethnic groups in 130 countries. While more attention is needed to fully access the potential of edible insects, they provide a natural source of essential carbohydrates, proteins, fats, minerals and vitamins, and offer an opportunity to bridge the gap in protein consumption between poor and wealthy nations. Many insects contain abundant stores of lysine, an amino acid deficient in diets of many people who depend heavily on grain. Some argue that the combination of increasing land use pressure, climate change and food grain shortages due to the use of corn as a biofuel feedstock will cause serious challenges for attempts to meet future potential demand. In Thailand, two types of edible insects, cricket and palm weevil larvae, are commonly farmed in the north and south respectively. Cricket farming approaches throughout the northeast are similar, and breeding techniques have not changed much since technology was introduced 15 years ago. Small-scale cricket farming involving a small number of breeding tanks is rarely found today, and most of the farms are medium or large-scale enterprises. Community cooperatives of cricket farms have been established to disseminate information on technical farming, marketing and business issues, particularly in northeastern and northern Thailand. cricket farming has developed into a significant animal husbandry sector and is the main source of income for a number of farmers. In 2013, there are approximately 20,000 farms operating. Total production over the last 6 years has averaged around 7,500 tons per year. Therapeutic foods. In 2012, Dr. Aaron T. Dorsey announced that his company, All Think Bugs, had been named a Grand Challenges Explorations winner by the Bill and Melinda Gates Foundation. Grand Challenges Explorations provide funding to individuals with ideas for new approaches to public health and development. The research project is titled Good Bugs, Sustainable Food for Malnutrition in Children. Director of Pediatric Nutrition at the University of Alabama in Birmingham, Frank Franklin, has argued that since low calories and low protein are the main causes of death for approximately 5 million children annually, insect protein formulated into a ready-to-use therapeutic food similar to Nutriset's Plumpy Nut could have potential as a relatively inexpensive solution to malnutrition. In 2009, Dr. Verkusi from Ghent University in Belgium has proposed that insect protein can be used to generate hydrolysates exerting both ACE inhibitory and antioxidant activity, which might be incorporated as a multifunctional ingredient into functional foods. Additionally, edible insects can provide a good source of unsaturated fats, thereby helping to reduce coronary diseases. Indigenous cultivation. Edible insects can provide economical, nutritional and ecological advantages to the indigenous populations that commonly raise them. For instance, the mopane worm of South Africa provides a flagship taxon for the conservation of mopane woodlands. Some researchers have argued that edible insects provide a unique opportunity for insect conservation by combining issues of food security and forest conservation through a solution which includes appropriate habitat management and recognition of local traditional knowledge and enterprises. However, Senior FAO Forestry Officer Patrick Drust claims that among forest managers, there is very little knowledge or appreciation of the potential for managing and harvesting insects sustainably. On the other hand, traditional forest dwellers and forest dependent people often possess remarkable knowledge on the insects and their management. Pest harvesting. Some researchers have proposed entomophagy as a solution to policy incoherence created by traditional agriculture, by which conditions are created which favor a few insect species, which then multiply and are termed pests. In parts of Mexico, Spinarium purpurescens is controlled by its capture and used as food. Such strategies allow decreased use of pesticide and create a source of income for farmers, totally nearing $3,000 per family. Environmental benefits. The methods of matter assimilation and nutrition transport used by insects make insect cultivation a more efficient method of converting consumed matter into biomass rather than rearing traditional livestock. More than 10 times more plant nutrients are needed to produce 1 kilogram of meat than 1 kilogram of insect biomass. The spatial usage and water requirements are only a fraction of that required to produce the same mass of food with cattle farming. Production of 150 grams of grasshopper meat requires only very little water, while cattle requires 3,290 liters to produce the same amount of beef. This indicates that lower natural resource use and ecosystem strain could be expected from insects at all levels of the supply chain. Edible insects also display exponentially faster growth and breeding cycles than traditional livestock. Insects generally have a higher food conversion efficiency than more traditional meats, measured as an efficiency of conversion of ingested food or ECI. While many insects can have an energy input to protein output ratio of around 4:1, raised livestock has a ratio closer to 54:1. This is partially due to the fact that the feed first needs to be grown for most traditional livestock. Additionally, endothermic vertebrates need to use a significantly greater amount of energy just to stay warm, whereas ectothermic or cold-blooded plants or insects do not. An index which can be used as a measure of the efficiency of conversion of ingested food to body substance. For example, only 10% of ingested food is converted to body substance by beef cattle versus 19 to 31% by silkworms and 44% by German cockroaches. Studies concerning the house cricket provide further evidence for the efficiency of insects as a food source. When reared at 30 degrees centigrade or more and fed a diet of equal quality to the diet used or reared conventional livestock, crickets showed a food conversion twice as efficient as pigs and broiler chicks, 4 times that of sheep and 6 times higher than steers or oxen when losses in carcass trim and dressing percentage are counted. Insects reproduce at a faster rate than beef animals. A female cricket can lay from about 1,200 to 1,500 eggs in 3 to 4 weeks, while for beef the ratio is 4 breeding animals for each market animal produced. This gives house crickets a true food conversion efficiency of almost 20 times higher than beef. For this reason, and because of the essential amino acid content of insects, some people on ecological grounds propose the development of entomophagy to provide a major source of protein in human nutrition. Impacts of animal agriculture. According to the United Nations Food and Agriculture Organization called the FAO, animal agriculture makes a very substantial contribution to climate change, air pollution, land, soil and water degradation, land use concerns, deforestation and reduce of biodiversity. Land use. Animal livestock is the largest anthropogenic user of land. 26% of Earth's ice-free terrestrial surface is occupied by grazing, while feed crop production amounts to 33% of total arable land. Livestock production accounts for 70% of all agricultural land and 30% of the planet's surface. According to the Food and Agriculture Organization, livestock activities such as overgrazing, erosion and soil compaction has been the primary cause for degradation of 20% of the world's pastures and rangeland. Animal livestock is responsible for 64% of man-made ammonia emissions, which contributes significantly to acid rain. By extension, animal waste contributes to environmental pollution through nitrification and acidification of soil. Disadvantages. Spoilage. Researchers from Wageningen University of the FAO published an evaluation of the potential of edible insects as a protein source in August 2012 issue of Food Control. The researchers found that spore-forming bacteria are a potential spoilage and safety risk for both cooked and uncooked insect protein. While more study is needed before integration into the food supply, current data suggest that while edible insects must be processed with care, simple methods are available to prevent spoilage. Toxicity. In general, many insects are herbivorous and less problematic than omnivorous. Cooking is advisable in ideal circumstances since parasites of concerns may be present. But pesticide use can make insects unsuitable for human consumption. Herbicides can accumulate in insects through bioaccumulation. In some cases, insects may be edible regardless of their toxicity. In the Carnia region of Italy, moths of the Zyganidae family have been eaten by children despite their potential toxicity. The moths are known to produce hydrogen cyanide precursors in both larvae and adults. However, the inclusives of the adult moths contain cyanogenic chemicals in extremely low quantities along with high concentrations of sugar, making zygena a convenient supplementary source of sugar during the early summer. The moths are very common and easy to catch by hand, and the low cyanogenic content of the inclusives make zygena a minimally risky seasonal delicacy. Cases of lead poisoning after consumption of chapulines were reported by the California Department of Health Services in November 2003. Adverse allergic reactions are also a possible hazard. Cultural taboo. Within Western culture, entomophagy, barring some food dyes such as carmine, is seen as a taboo. There are some exceptions. Casu marzu, for example, also called casu mude, casu cundidu, or in Italian formaggio maricchio, is cheese made in Sardina notable for being riddled with live insect larvae. Casu marzu means rotten cheese in Sardinian and is known colloquially as maggot cheese. Western avoidance of entomophagy coexists with the consumption of other invertebrates such as molluscus and the insect's close arthropod relatives crustaceans, and is not based on taste or food value. Public health nutritionist Alan Dangor has argued that large-scale entomophagy in Western culture faces extremely large barriers which are perhaps currently even likely to be insurmountable. Anthropologist Marvin Harris has also suggested that eating of insects is taboo in cultures that have other protein sources that require less work to obtain, such as poultry or cattle, though there are cultures which feature both animal husbandry and entomophagy. Examples can be found in Botswana, South Africa and Zimbabwe, where strong cattle raising traditions coexist with entomophagy of insects like the mopane worms. The international policy. The Food and Agriculture Organization has displayed an interest in developing entomophagy on multiple locations. In 2008, the FAO organized a conference to discuss the potential for developing insects in Asia and Pacific region. According to Durst's, FAO efforts in entomology will focus on regions in which entomology has been historically accepted but has recently experienced a decline in popularity. In 2011, the European Commission issued a request for reports on the current use of insects as food, with the promise that reports from each European Union member state would serve to inform legislative proposals for the new process for novel foods. According to the NPR, the European Union is investing more than $4 million to research entomophagy as a human protein source. Thus, to conclude, insect as human food is prevalent in many parts of the world, and a large amount is spent on research work to find out if there are many more advantages of eating insects.